Hello everyone, this is Connor Willens with Zorbix Technologies, and we're here today to give an overview of some of the most useful tools for data governance, ETL, and machine learning on Databricks. To give a little background, Zorbix hosts a Databricks user group in the Wisconsin area, and this was from our Databricks Data Plus AI workshop. Two of our software engineers, Ryan Shiva and Tyler Faulkner, ran a live, hands-on lab, so this video will be showing some of the highlights from that. In the demo, they'll be using data from wind turbines to view energy output, determine whether or not they are damaged, among other information. I'm going to let them take it from here, so enjoy.
So now let's kind of talk about our data a little bit. Ryan gave us a basic introduction earlier. So to go more into the actual tables, fields that we're going to be seeing here. So we're essentially going to have three tables to kind of build out our whole pipeline on top of. We're going to have the turbine metadata, which is turbines, their ID, their location, and a bunch of other metadata info about each of our turbines. We have our sensor stream. So each turbine has, I believe, like 6 to 8 different sensors. In this case, they're all labeled like A through D. And all of these are, I'm not sure in the exact period of time, but let's say every second they're producing a new JSON with their current stats into this bucket. So there's a whole bunch of JSONs that they're all producing. It looks like, in this case, vibration, energy to produce, speed for each of these sensors are all being dropped into this bucket. The last big table that we're going to be using is the turbine status. So this is kind of hand-labeled data that's been used in the past, manually created by some probably data scientists, data engineers, and that's going to eventually be piped into our machine learning model for its training, which Ryan will talk about in a bit. And one other point I want to note before we actually start looking at some code is I want to talk about the medallion architecture for a moment. So the medallion architecture, essentially you're moving from bronze to silver to gold data. So essentially what that means, bronze is this first layer here. So kind of that raw data. It's being pulled from, essentially, as you can see here, JSON, CSV. It's being pulled from those sources into Databricks. And we're not doing any really processing on top of those except maybe some change data control to keep track of when new JSONs are coming into the system. But other than that, it's essentially raw data put into a SQL-like table. And then the next layer on top of that is kind of where we perform aggregates. We kind of clean up the data a little bit so it's more usable for other solutions. So that's what we call our silver layer. And in this case, we're going to build a table called sensor hourly, which is going to be kind of our average data over an hour-long period for each of our sensors. And then the final layer on top of that is our gold layer, which in this case is going to be our training data for our turbine. And gold layer essentially means that it's ready to use either for a dashboard, which I'll show off in a second, or for an ML model, which Ryan will be showing. So now we're going to start that first step, the bronze layer. We're going to ingest this data into Databricks, create some tables to store all that data that we have, all our streaming data. So we get some nice benefits from using Databricks here. So one of the things is schema inference and evolution. So we can create logic. There's kind of built-in logic in Databricks. So as, let's say, a new JSON comes in, it's got a new column in it, we can automatically evolve the tables if we needed to as new fields are added and or removed. Scalability built into Databricks, and a lot of the simplicity just from being able to do this directly through SQL queries. So now I'm going to walk through some of the queries to create this kind of bronze layer. These are all going to be what are called Delta live tables. We're using the streaming keyword here, which is kind of a subset of live tables. So you can kind of think of a live table as a materialized view. Essentially, it knows what operations it needs to perform to build its data, and it's going to automatically run those operations whenever the table is dependent on changes. So in this case, a streaming table isn't dependent on another table, but rather from raw files sitting in a bucket somewhere. So we have our turbine data. We have a constraint on it. So these are our data quality checks. So we just want to make sure the rescue data is null, which is a feature from Databricks for recovery efforts. If anything goes wrong, it labels it as rescued data. So this is just saying we don't want any of that rescued data directly into this table. We can leave comments on the tables, which is nice just to know exactly what this table's for. So turbine details of location, wind turbine model, etc. And then this last part here, where we're actually pulling the data from, we're using a custom function called cloud files, which is essentially just telling Databricks, OK, I want a certain type of file. Here's the location. Here's the file type. And here's how to map the keys in that file type to our new table. So first thing we're going to give it is the location to our files. In our case, we have when we installed all the demos, it created a folder which contained all our turbine data. So we're pointing it there. We're telling it everything in here. We just want to read all the JSON files in here. And then this last part is telling Databricks to essentially infer the column types. So you can give it an explicit declaration for each column type. In this case, we're going to say, just look at the JSON, whatever's in there, we're going to use as our column types for this new turbine table. Our next layer is our silver layer, which is going to be kind of our aggregated data over hourly timestamps. So here we're using the live keyword, and this is telling Databricks, again, that this is a live table, essentially materialized view. So this one's dependent on sensor bronze. So whenever sensor bronze updates, we need to update the sensor hourly table. So we have our standard deviation for each sensor. We have the approximate percentile for each sensor and average energy for each sensor per hour per turbine, or per turbine per hour, I should say. It's kind of just our data cleaned up, like I was talking about, put into a more usable format to kind of be used in other places. So this next layer is going to be our gold layer, our gold table. So we're going to join the data together with the metadata and the historical status to build a more complete table so we can use this in a dashboard or for model inference. So now we're creating another live table. So it's telling it, again, materialized view, update when sensory hour updates. And this is also linked to turbine and historical turbine. So if either one of those updates also, it'll also update the values within this new gold table. So I've ran that. So now we've gone through all our layers. So we have our bronze layer, which is our raw data, silver data, which is kind of our cleaned up. In this case, we're aggregating it by hour. And then the final layer, our gold table, is our data set we're going to use for training. So cleaned up even more, has all the columns we need put together into one, and now it's ready to go to be passed off into training. So there we just went through a whole medallion architecture, very simple one, but it highlights the points of cleaning the data through different tables. So that kind of concludes the first portion of this data, is pulling it all in, putting it into Delta Live tables, and having it be ready to use with data governance using Unity Catalog in Databricks and machine learning, which I'll pass off to Ryan so he can talk about.
Thanks a lot, Tyler. So Unity Catalog, it's a feature on Databricks. It provides security and governance for our data, and it will work with multiple objects in the lakehouse, not just like your tables, but also machine learning models, files, volumes, etc. It automatically provides data lineage and also audit logs on your data, which is really helpful. The automated data lineage will let you see where the data is coming from, and you could also see what teams or projects are using what data. And then for the audit logs, you can see a record of access to your data. So anytime somebody queries a table, you could see a record of that. So very useful, available out of the box for you. It will work for structured and unstructured data. It will also work for things like notebooks and dashboards. You can grant different access to different teams. So like, let's say, for example, you have data analysts, data scientists, or data engineers. You could create different groups in Databricks and provide different levels of access. And it could get very granular. So like down to the row or column level of an individual table, or you could grant access to an entire catalog and have those permissions be inherited. It's very easy to have multiple teams collaborate in the same workspace, and then each team only has access to what they need. So you could imagine that also simplifies things like regulatory compliance. If you're working in another platform such as AWS with IAM policies, those could get very complicated. So it removes that complexity. Basically, you can manage all your permissions in a single place, and it works across all your workspaces in the Databricks account. So going back to the Unity Catalog notebook, I'll show you how to actually grant access. So like I was saying, this could be done in the UI or could be done programmatically. So you use this grant select on table syntax, and you could use that to assign a permission to a group on an individual table. The permission we're assigning to the analyst group is select. This will give the analysts read-only access to the tables, so they could use that to create dashboards, but they won't be able to do things like modify the table schema or write or delete the tables. Now down here, I'm going to show you how to grant permission, not just on a table, but actually a schema. So at DB Demos IoT Turbine, we're granting both select and modify permissions to data engineers, granting this to the entire schema. And what happens is all of the tables contained in DB Demos IoT Turbine schema will have the same permissions for the data engineers group. The permissions are inherited downward from the schema to all of the tables and volumes contained within the schema. So you could also view and edit these permissions in the UI. So go back to the catalog section. You could control the permissions here. I'll click grant, and then you could see you could specify an individual user or a group that's been created. And then you see these different options and it explains what it can do. And now you can see the privileges that are granted on an individual table here in the UI. So it does not require code to do that. Next, I'm going to talk briefly. Unity Catalog enables a feature which is called delta sharing. So this is something that lets you share data to a different organization outside of Databricks. And this will happen securely, and it will work with a variety of cloud vendors or data stacks. We're not going to get too deep into that in this demo specifically, but you should know it's a powerful feature of Unity Catalog. So that's all I have to show for Unity Catalog. If there's no questions, I could switch over to talking about machine learning. So in this next section, I'm going to show you guys some of the ML capabilities of Databricks and show you how to train a machine learning model. So this is going to use the data that we ingested in the DLT pipeline, and it's going to help us optimize energy production. It could help us reduce maintenance costs by predicting when turbines are faulty, and it will help us reduce downtime because we can more quickly order parts and service. So I'm going to show you how to build a predictive maintenance model. We're going to use this to classify, it's called a classifier, and we'll try to predict for each turbine whether or not it's faulty. And to do that, we're going to read IoT sensor data, and it's been enriched with turbine data in the pipeline. Briefly, kind of the different steps of training a model on Databricks or another platform. You would start with data exploration. This is to analyze the patterns in your data. You could identify data quality issues. You figure out what kind of relationships are in your data. So like whether it's linear, logarithmic, et cetera. And then you build features for your data, which are basically the attributes you input into your model. After that, you train the model, and you could use your preferred tool. Databricks supports a lot of Python libraries that are popular, such as scikit-learn, SparkML, TensorFlow, things like that. After you've trained your model, then you can review evaluation metrics. So like RMSE is really popular, root mean squared error, and that will help you determine the best performing model. After that, you're ready to deploy your best model to staging and then production. MLflow has a feature called Model Registry that helps make that really simple. You could do that in the code, or there's also a UI right over here, the little models button on the left. And then once your model's deployed, then you can run inference. So that could be either batch scoring or real-time predictions. You can deploy your model to a REST API endpoint. Again, Databricks has built-in tools to help you do that. So first, I'm going to show you a little bit about data exploration. So down here, I've got a cell which will help me create a couple of graphs. Here we're defining a function called plot, and it takes a parameter sensor report. So we could pass in the name of a particular sensor, or we could pass in OK. Let me just show you in the turbine training dataset ML. If I run this, you'll be able to see the output in a data frame. Okay, so you got this abnormal sensor column. And you could see for each turbine, you've got a turbine ID, and this column will determine was there an abnormal sensor. If not, the value will be okay. And if there was an abnormal reading from a sensor, then it will give you the name of the sensor. And so now this plot function down here, you're passing in either the name of a sensor or you pass in OK. This function will get a turbine ID. So we're only showing data in these charts for a single turbine, grabbing that turbine ID. Then we filter the data in sensor bronze ML. So remember, that's our raw ingested turbine sensor stream, which is the IoT data from the turbines. Filter that by the ID, put it in chronological order, and then this function will convert it to a pandas data frame. It's pandas on Spark, so it will still work with our distributed Spark cluster, but it allows us to use this plot function on the data frame. So looking down at the actual graphs, when we're graphing data, this would be for the OK data, and then this is the sensor B anomalous data. You could see the difference in the two graphs. The OK data has a much smaller range from -5 to 5, most of the data points, whereas the sensor B anomalous data goes from like -30 to 30. So there's a lot more anomalous readings for the data for this turbine where sensor B is recorded in that anomalous reading column. So as you can see, there's powerful tools in Databricks to visualize and explore your data, to identify different trends and help you determine what features to use, how to prepare your data for the machine learning model. So now that we're done exploring our data, we could actually do some data preparation, and we're going to use something called pandas on Spark. which pretty much lets you work with pandas data frames and pandas instructions, but you distribute the workload over multiple Spark threads or VMs. And we configure that with our cluster, which Tyler already walked you through. But since we've got multiple cores in this cluster, Spark will handle this in a distributed fashion, but we still got the pandas library and pandas syntax and working with pandas data frames. And the pandas API function is how we get a pandas on Spark data frame. So down here in this cell, this is a very common featurization step. We create our pandas data frame, then we drop the columns that we don't need. So this end time and start time, we want to get rid of the columns that are not going to be used for training the model, because the more columns you have that are not relevant to the prediction, the more noise you're going to have, and your model will be less accurate because it's trying to use noisy values that aren't correlated with what you're trying to predict. In this case, damaged turbine or not. So that is a very common featurization step. And another data preparation step we're going to do is this drop NA function is going to drop missing values. So we're looking for null values in the data set and drop those from the data frame. And now we could use this function describe, and this will generate summary statistics like mean, min, max value, standard deviation, the median right here. So after that, once we have our data frame ready, we're going to do something called writing to feature store. Feature store is a feature in Databricks. It lets you access your features in a central location. Like I said previously, features are the attributes that you use to train your model, and they're cleansed and prepared in a certain way, depending on whether they're like numeric or categorical. And so this is a way to basically like discover and reuse features across your whole organization by logging them to this central location. The feature tables in the feature store are stored in Delta format, so that gives you all the same ACID guarantees, the time travel, the traceability, and the governance that you get on normal Delta tables in your workspace. First, I'm going to show you how to create a feature table programmatically, and I'll also show you a bit of the UI where once the table's created, you can see the table columns and the features you have available in the store. So I need to create a feature store client here. And then you've got this create table statement where you're passing in a few parameters. You specify the name of the feature table. So we're using the catalog name, the schema name, and then the name of the feature table, turbine hourly features. The primary key is necessary to make sure that each record has a unique key for retrieving records. When you create the table, you need to either specify a schema or a data frame. In this case, we're specifying a schema so that we know the column types of each column in the feature table. And then you could optionally specify a description as well that'll show up in the feature store UI. Once you've created your table, then down here, we're calling this write table function. Here, we're actually providing a Spark data frame to the feature store client and writing that to the feature table. We're accessing it with that feature table name that we provided up here. The mode is overwrite, meaning that if there was any data in this feature table, which there isn't because we just created it, if there was, all that would get overwritten by this data in the data frame that we're providing. After that, this read table function allows us to read the data back out of the feature store table. We just pass in the table name, and you can display that as a data frame. You can see that down below here. So next, I'm going to go to the feature store UI. You could access that with this features tab over here. So I'm just going to click on that new table we created for the turbine hourly features. And now you can see we've got the columns, the data types, and then you could see the same lineage and history. So you could see when it was created, for instance, and you could see when it was accessed if I had a warehouse running. Let me go back to the machine learning notebook. So next tool I want to show you it's a couple of really powerful tools on Databricks called MLflow, which you already got a glimpse at, and then AutoML. MLflow is an open source project, and it lets you track models. It also helps with packaging and deployment. MLflow can track all the parameters and the data that you use when you're training your model, and it will save it in a centralized location. You can really easily know what model was built using the different parameters and data. AutoML is a tool that lets you automatically generate models for classification and regression and forecast. So in this example, we're going to use it for classification. You can provide the data set and identify the prediction target, and AutoML will prepare the data set for you automatically and train the model and all that. Once the model's been trained, evaluated and trained, but the best model is identified, AutoML will display that for you, and it provides notebooks with the source code, so you can view that and also build upon that. A lot of data scientists would use AutoML as a starting point to identify like what's the best Python library to use, what were the best hyperparameters, and then they can work from there and tweak it to optimize performance in the model. AutoML will also calculate summary statistics for you, and it will save it in a separate notebook so you can review that. So I'm going to show you how to run AutoML. Down here, you can run this programmatically. We're using AutoML, the classify function, because we want to build a classifier, and then we're defining some of the parameters here. But you could also really easily do this in the UI. So I'm going to go to the experiments page. So here in the experiments page, we could see all of the experiments that we've run when training models. Each of these experiments in Databricks kind of corresponds to a single notebook, but like you can imagine, if you're running a notebook multiple times and tweaking the parameters of the model in different runs, these will be organized for you in what's called an experiment. You could see multiple runs for each experiment. And we've got this button at the top right called Create AutoML Experiment, and I'll click that to show you how to do the same thing we were doing programmatically in the notebook, but I'll do it in this UI. So you need a running cluster. You want to select classification type because we're trying to predict true or false is the turbine faulty. And then we grab the training data set. So what we want is this DB demos IoT turbine hourly features. So this is that feature store table we created. Our prediction target is going to be this abnormal sensor column. Remember, that's whether or not the sensor is anomalous, detecting an anomalous value or not. And one more thing we need to do is down here, these are our features, but we want to make sure that we uncheck turbine ID. And the reason is because this isn't a feature, it's the PKID of the table. So it identifies, it's a unique identifier for each record, but that doesn't help us predict anything. So we don't want it to be included when we train the model. All right, so then you just click this Start AutoML button, and it will run a whole bunch of different models for you using different Python libraries. It will search across a space of different hyperparameters for each notebook, and then it will automatically find the best notebook for you and display it. So I'm going to go back to experiments while that's running, and I'm going to go ahead and get a previous run that I've already done. So here you could see the list of all the different runs that AutoML created and trained automatically. It found the best one for me, and there's actually this really convenient button so I could view the notebook for the best model. So the best model was using XGBoost classifier, which XGBoost is a Python library. You could view the code that was used to load the data, explore the data, pre-processing, handle numerical and categorical features. Like with categorical features, you need to do one hot encoding, so it shows you how to do all that. It'll show you the train test split, and it will show you how it actually trained the model. You could see the code that was actually used to define and train and log the model. So all this, you could see it's a very good starting point to either use this to train the model automatically, or at least you've got all the code so your data scientists can avoid doing a lot of boilerplate stuff. They've got all this auto-generated for them. Now I'm going to go back to the ML notebook. I just want to briefly mention, so we're using this AutoML model, and we want to display the prediction whether wind turbines need maintenance in the dashboard. So let me go up and show you in this dashboard. So we've got this dashboard, wind turbine predicted maintenance. And here you could see like what % of production loss due to turbine malfunction. And you can see like the number of damaged turbines. So as you can see, it's a really useful way to visualize the results of your model in real time. So that's all I had to share. Thanks everybody for your time. I really appreciate it.
So there were a couple of useful tools for data governance, ETL, and machine learning on Databricks. If you're in the Wisconsin area, we encourage you to join the user group for upcoming events on wisdbug.com. If not, you can subscribe to our channel, as we'll be posting more videos like this from future meetings, as well as other Databricks content. If you want to explore Databricks solutions for your company, contact us at zorbix.com. But that's all from me. Thank you for watching, and have a good one.